Good morning. Well, we're actually going to be doing work today, which is not what we've been doing for the last couple days. Last couple days have been just playing some games, relaxing. We finished our milestone, and well, here we are. So I'm just waking up, and what I'm going to be doing is I'm going to be going over some of my previous sprints, grabbing data off of them to see like how much we got done, and then I'm going to be basically estimating how much we will get done over the next like X number of months to see if like we're going to just completely fail at our project or not. So I need to open up a whole bunch of these previous sprints. We keep stats on ourselves every single week, and those stats are what we got done, what we wanted to get done, and everything like that. So when we get something finished, we mark it down, and we can actually figure out kind of what we're trying to do. So I'll go through for all of these sprints. All right, and we have the remaining. When did we stop using the formula? Right there. So we're just using the magic of spreadsheets to actually do a lot of this. What this will show us is basically like if there's any patterns we can glean from the data, such as, well, when we attempt to do a whole bunch in one sprint, or we put a whole bunch on our plate, maybe we don't know where to start and we don't get as much done. We might look at if there are any patterns that we can pull apart, or we can see if there's any like real problem areas, like, well, what was happening that week? What are we doing? Why did everything go wrong? And it's important to go back and look at what you've got in the past and see if there's anything you can kind of pull out of it. At least that's the theory. So let's see, we need to edit these graphs, don't we? So it needs to not be W2, but AD2 for all these. And it's not always the most interesting thing on the planet to go over stats and numbers and everything else, but it's an important part of trying to figure out if you're doing what you're supposed to be doing correctly. And normally this is what your leadership team is doing, or at least a lot of the time this is what your leadership team is doing. Trying to see exactly. Adam's got different kind of sprint numbers here, so gonna see if he actually picked all the dates up properly, because I can at least sync up the dates with what we've got. So let's see. 15. So we had 56 and we got 51 done. And Adam uses different numbers than I do for everything. So the numbers are just consistent with themselves. They're not consistent with anything else. Just themselves. Actually, I should probably go back and look at 14. Make sure it actually got updated properly. Yeah, it looks like it wasn't. Alright, so 17, we had 38 and 32. 18 was 41 and 37. 19 was 42.5 and 42.5. 32.5, 22.5. Let's make sure we got the latest. One of the things we need to do also is make sure to kick off a build for that we're going to be sending to our hopeful to be composer. So make sure we have that build rolling, and then I can test that out later in the stream. I'll kick that off on the build machine. Let's see, this is 26 and 23. This needs to go to AF. Oops. So we'll go here. This is AD and AD again. I'm clicking the wrong frickin' things. Excuse me. So let's see if there's anything we can glean from some of this. I'm also going to try to pull up the number of let's see, is there like maybe 12 slash 1 slash 2017? So let's just throw in like a let's just say December 1st, or why don't we pick that Sunday, and then we'll just have like equal today. We'll actually do this minus today, so that's how many days, and this is going to be this divided by 7, which will be how many weeks we've got. And can we do maybe a math, maybe a round? So this is how many sprints we have from today until the end of it. And what we can actually do here is we can say what was our average like velocity over all this. So we just keep updating all these fields basically. And we actually when you subtract 23 from this, I think, or 22. So we can kind of plot basically what's going on with everything. Are these accurate? So this is all of this, and it's divided by 80/27. It should be 26. That's 83. Alright, good. So this will give us our average velocity for what we've been getting done and everything like that. And so we've got like our, we can then do estimates like, okay, so basically we should be able to say this is like work we can do. Reasonably. Until, you know, the end of the year. Oh, come on, Google Docs. Don't do me like this. And again, our numbers are very different in terms of what they represent, so Adam having a higher number here for the amount is not actually, I'm actually more full-time, so I probably have more overall work that I can get done just because I have more time. I just estimate things in much smaller units or smaller units. That's just kind of what we do. So let's see. Let's take a look at our patterns. Let's also look at the number of tasks that we have on our backlog. I will just because basically law of large numbers is if we have enough randomness in our data, we can actually make very good estimates even if we don't know what we're doing. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 35, 36, 37, 38, 39, 40, 80. 90, 100. Let's just throw 100 on here for that. It looks about the same for design, so we're just going to do 100. And let's say the average task size, let's say it's 3. Let's actually normalize it. If it's 3 for me, it's 6 for Adam. We'll just put it at maybe like 5 and 10. So, I mean, these are just general numbers, but basically what this says right here is based on all the data that we've got for our project and our rough, very rough estimates of just like, let's take all the tasks and just make them all the same size in terms of how big they are. And a 5 for me is like, this is a full day of work plus more. So, I mean, this is more like 2 days worth of work is a 5 for me, or 2 or 3 days. And same for Adam. I think 10 hours is, I think he's got like 30 hours every week. I mean, we can just look at how many hours every week he actually has. And that's going to be like, work per week is going to be this times 7. So yeah, for me, you know, I'm getting 16 units of work done every week. Adam's getting 32. So basically what this means is if everything magically, you know, comes together, etc., exactly as it is right now, we would estimate that by the end of the year, we would be 85% of the way through the work that we want to be done. So obviously that's a problem, but it's not a massive problem, right? Like 85% of our work, that's the wrong page. These are stats. 85% of the work is not like that. These numbers are 85 and not like 50 or 30 or 40% is really what matters for planning, because basically it's a gut check and you can be optimistic or pessimistic. And if you find yourself going like, well, our average tasks aren't 5, they're 3, right? And then you're like, oh, we're totally on track. In fact, we have extra budget and we can do all sorts of stuff. You know, sure, we'll make like a multiplayer game and a mobile game, and we'll have, you know, this little animated short here and all this other stuff. And it's just important that you always don't you catch yourself from doing that. So you want to be okay with pessimistic outlooks on your schedules, because pessimistic outlooks are actually pretty easy to work with. Because I mean, well, if you think about it for a minute, if I think about it for a minute, for me, if I'm like, okay, I need to do X amount of work in Y amount of time, like that means I need to, you know, I don't have enough time, I have to do things. You know, I have to cut things. That's easy to do. That's easy to just say, well, we're not doing that, and we're not doing that, and just throw off entire segments of work. But working in a more optimistic schedule where you have more time maybe than you need, you have to come up with tasks to fill the time. You're like, oh, we have like extra time to do all this stuff. We could do all these things. So when I'm running schedules, usually I try to keep kind of like at that 90% mark, because it's always easy to chop off like the last 10%, or it's easy to bridge, you know, a 10 to 20 point swing. It's impossible to do that for like a 50 point swing. So let's take a look at our velocity graphs. So it looks like over the course of our weeks, we're pretty stable. Looks like we have every other week we do more work than the previous one. Like, it's very clear here that my schedule, I will do more work and then maybe take a couple days off. But that's not impacting anything too badly. Our estimated work versus our completed looks pretty good. Like, I don't see like this, if this line was big and then this one got really small or something, it looks like they're pretty close to each other. In fact, you could almost argue that they're kind of offset from each other. So that doesn't really indicate a problem, I don't think. Let's take a look at Adam's graphs. Looks like he gets a lot done on the weekends, which is what he does, and it's usually every other week, which is exactly what happens. And his estimated versus completed, looks like he's very picky about this always lining up, which may indicate a problem. Like, these graphs really shouldn't always just line up like this. It means that you're getting exactly what you wanted done. And sometimes what that can mean is you're making compromises in order to claim things being finished, such as, well, this is good enough. We just have to be done today. Versus, maybe we can have some more time to make this thing better. And this is usually what you find. This is pretty standard when you ask people to do tasks, because I do most of the planning for the project. So, of course, what that means is Adam doesn't want to change any of the planning stuff, because I put all that together, and as a result, he probably feels some pressure to get stuff done, which is exactly what happens in regular business. And I, of course, don't give two shits about getting all my stuff done every single week, because I control the master schedule, right? I can I can just magic another week in there if I want to, so it's easy for me to just make decisions, because that's kind of my part on the project. But what this says is we're doing well. We're on track. There are some red flags here. If we're going to ship everything we want by the end of the year, we may have to end up cutting things that we don't want to cut. But we have plenty of time between now and then to get there. So if we estimate it right now, we are by the beginning of December, we'll be at sprint 50. And right now we're at sprint 22. So we are less than half of the way through the project. So we're doing great if this is where we are right now. So that's our stat tracking, and that is now updated nicely for us. So let's move on to fixing the build here. So we've got let's make sure we're all compiled up. We need to make sure we have a good, solid, playable build here for our composer. So Adam put together his level. I'm going to make sure it works on my machine and he's got everything checked in, because that's an easy thing to miss. And we love our compile times, don't we? Actually, this is more the Unreal header tool running. When's the last time I updated the dev blog with anything? May 14th? Might be time to write an update for that thing this weekend. Oh, we could look into that. Maybe I should add that to my current sprint. Why don't we just do that? Alright, so I think it's Adam's new level that I got, so crack that open and see what we got to work with. Let's see, I believe it's the beautiful corner 1705. Because 1704 sucked, so 1705 is more what we were doing. Oh wow, he's done some tuning. That waterfall though. I think I know what he's going for. Oh man, what is this? That is a gigantic log. Bitey feels like he's in space. Oh man, look at all this. It looks really cool. Okay, so this level looks fine to me. So what we want to do is go into the editor settings. And I think it's inside of maps and modes. Yeah, so we want the game default map and we want to set that to the beautiful corner 1705. And make sure to save that. We don't want to save the level itself. So let's just make sure we got that saved. Let's make sure we got the right thing. Yeah, so that's the beautiful corner, and we've got all that. So I can check that in. And then I can go kick off a build. And that'll be done in about 20, 30 minutes, maybe. So I set a countdown timer. Alright, so we'll have that going in the background. And we need to move on to what we're doing next. So we're doing next. Alright, we need to figure out a couple things with this texture sampling. So we've got an issue right now with our texture sampling, which is that I'm not really sure exactly what's going on since we're not incredibly familiar with the material system. But I need to read up on how the textures work and figure out why lighting is super screwy with our with our paper 2D stuff. So, like what I want to do here is I want to zoom way in on Bitey. So let's see what we're using right here. So our standard player is using our Bitey player, which is using our standard camera. And I think I want to use the close-up camera. Let me just see where that is. We have like close-up camera. Why don't I just duplicate this thing, and I'm going to call it Bitey close-up player. And I'm going to use the close-up camera for it. And then I just swap our player controller object here so that we're using the close-up player. Let's see, yeah, so we're a lot closer now. I actually want to go closer than this. And I want to disable a lot of stuff. I want to disable the zoom, I want to disable the direction, and we're going to get even closer to Bitey, because we want to really take a look at what is going on with his texturing. I probably also want to put him right here. So this texture looks like it's all sorts of messed up, right? Like it's glowing. Like Bitey should not be glowing right here. So why is he glowing? Well, if we go to his character, like he's glowing here too. So actually we don't even need to do anything crazy. We can actually view him in the viewport here. And he should be looking like these guys, right? And this is breed. Like how it doesn't show the actual folder. Show in folder view. Alright. There we are. So, what we've got for these textures is... This is an actual sprite sheet. 1024 by 1024. And the compression settings are... Because what we were saying, like, if I change these compression settings... He has a lot of textures for this. We changed all these to default. Check everything out here. So if we zoom way in here, you can see these artifacts are happening. Like, this is not Twitch or YouTube messing stuff up. Like, we actually have errors with sampling with our material. And I'm not sure why that is. Like, that's not what our texture looks like. So I'm not sure if it's the texture itself. I mean, it looks like it might be. Like, let's see if we change the we change it to that user interface. Yeah, you can see it actually. The compression matters. So I should look up the texture compression settings. Alright, one of the biggest contributors to any digital project footprint is the amount of textures. Unreal Engine is very good at reducing texture sizes. Alright, we have 1 to 8192. Alright, so there's a whole bunch of stuff about making it. DXT uses lossy compression based on packing pixels into 4x4 blocks. The results are video member and texture memory pool. Alright, so following tables list the texture memory requirements for DXT1 and DXT5. Alright, so we probably don't want a lossy texture compression for our sprites. Like, that's not going to work for us, I don't think. Because our whole game is sprites, and we need that to be pixel perfect, like Adam drew it pixel perfect. I'm surprised that the documentation doesn't really cover what the compression settings do. Maybe there's documentation here. No, nothing that specifies like exactly what these things mean. So I need Right, there's an actual forum post. What is all this crap? What does it do? Let's see what it says. So I looked up in the docs and there's no info on specific compression settings under the compression group. There are things like TC-HDR, and what are all they good for? Just check the size map feature with textures and different. Okay, so there's size map. If enabled, the texture's alpha channel will be discarded during compression. There's a size map thing? Where? Texture group, world. Let's see, global force resident MIP levels, preserved border. When true, the texture's border will be preserved. No. Power of 2 mode. Padding color is black, sRGB. Let's see if there's wrap, dither, never stream. Flip green channel. Whoosh. Filter. Well, we don't need a composite textures. Just check the size map feature with textures on different compression settings. Well, I don't see any size map setting here. So yeah, alright. So let's see if we just like scroll through these things real quick, then what actually changes. So if we start at the top, resource size is 1300, bitmaps is 11, DXT5 is what it's saying it's using. Maximum texture size, maximum resolution for generated textures values here means maximum size is dependent on the platform, which have a default resolution of 512. Right, we can change the MIP settings, which we really don't need to mess with too much. Global force, resident, MIP levels, preserve border. Alright, so we don't need to worry about the texture filter, it looks like, too much. So if we go through this is the same size, but it's using the same lossy compression. Masks, no sRGB. Compression setting to use when building a wish it would let us know. No sRGB. So it's just a mask. It's like black and white. Doesn't seem like that worked. Grayscale, it's still the same size, so. Displacement map? No. Vector displacement map? RGBA, 8. I mean, really what we should be looking for is not like vector displacement map and all this other crap. We should just be looking at like what the hell is the format for all this stuff. And this is DXT5, this is BC5, this is DXT5, so it doesn't matter. G8, I don't even know what the hell that is. Probably grayscale 8, so let's see, vector displacement map. Vector displacement looks like it doesn't have any lossiness, any loss in terms of the I can't pan. Alright, so let's see. HDR uses float RGBA, but RGB, no RGB. No sRGB. Well, what's the difference between the two? This is RGBA8, and this is HDR. HDR is... Alright, yeah, if we look at the sizes here, this HDR actually is a much larger texture. So I'm gonna write some of this down. Looks like the vector displacement, so it's B8 G8 R8 A8 equals vector displacement, which is 5461K. HDR is going to be it's going to be 10923K. So it's a much larger texture if we use it. Let's see, user interface is B8, G8, R8. So yeah, let's see, what's the... I don't see any difference between user interface 2D and vector displacement map. It's got the same stuff, so... It's still just RGBA8. Let's see, what is alpha? Alpha is BC4, and it's looking like it's just the alpha channel. No RGB BC4 on DX11. Okay, so this is lossy with that. All right, what's distance field? It's just the red channel. Just the red channel. I got HDR compressed, which it's float RGBA, so it's a float for every number. And it looks fine. Like, it looks like everything looks proper, but it's still 10K. This will be HDR compressed. 10923K. And BC7, DX11 optional A. This again is lossy, so we really don't want that. So it looks like probably what we want to do for everything is we could use HDR compressed, or we could use vector displacement. So I think it's vector displacement is what we're going to want. At least that's what it looks like. This HDR compressed might be higher resolution overall. Let's see if there's any difference if we go like way in here. If we switch between HDR compressed and our vector displacement. I'm not seeing any difference with this material. Let's see if we change the filters a little bit. So we can get like a pixelated bitey. Bilinear is much more smooth. Trilinear. Default. So yeah, I don't think we want to go with pixel bitey. It looks pretty dumb. Let's see, does it change the size at all if we do nearest? No, it does not. It doesn't do anything. Good morning, Karakan. We're looking into texture issues right now. Like, if you remember it all, we're having issues with those textures for bitey where some of them are looking really funky. And we're having issues like if we zoom way in here, the default looks like this. And if you look real close, there are artifacts in this picture. I don't know how well it comes up on stream, but you know, it's got those JPEG squares that look like garbage, and it's not noticeable on like a single frame. But if you zoom out, you kind of can start seeing it, and when you, especially when it's animating and the squares move, it looks really bad. So we're looking at exactly what the texture compression does, and what we can do about it. Yeah, exactly. We're trying to pick the right one, and it looks like we could probably get away with this vector displacement map. Basically, the RGBA 8, where we use 8 bits for the R, the G, the B, and the A. So we have 0 to 255, which I think is what we're doing anyway. So I don't think we need the HDR textures. I don't think we even have that information on the texture itself. So I think vector displacement map is what we need to go with for everything. Because that's what he looks like with the right now. And we don't want that. Alright, so if these are our textures, then we need to look at the flipbook for the breathe. So let's take a look at our materials. So let's see, we've got default lit sprite material, default sprite material, masked lit sprite material, masked unlit sprite material. That doesn't look correct to me. Like, why is he all weird looking? Opaque lit sprite material? What is that artifact? So we've got our translucent sprite material. The eyes are glowing in the sprite, so that's something else. But yeah, some of these. So it's pretty much this translucent sprite material is Translucent unlit sprite material is kind of what we want, but the question is, why in hell is it looking like this? Whoops. Way to close all your browser tabs, including Twitch chat. Oh, yeah, it's the alpha behind it, which is that's obviously something that we'll want to take out because you can just see the blending there is just absolutely wrong. Like because the sprite itself has the lighting baked in, it's blending with nothing, and it's going to look really bad. So the question is, so we should go to this translucent unlit sprite material inside of here and take a look at what it's actually doing. So if this is our material, let's see exactly what's going on with this. So we're passing things into our default sprite material with our emissive color, opacity, and all this sort of stuff.